Hello all and welcome back to our sessions on finite automata. Till now we have seen how to design regular expressions, then how to convert these regular expressions into NFA using the guidelines, then converting this NFA into TFA and finally into minimized DFA. But till now we have seen how to design NFA with epsilon. In today's session we will see the guidelines for converting NFA with epsilon to NFA without epsilon. So let's start our today's session. So here are the guidelines for converting our NFA with epsilon to NFA without epsilon. Rule number 1 or the guideline number 1 is the number of states will always remain the same. The number of states are never going to change. Rule number 2 is start state will always remain the same. Next step is final states will also remain the same. Now the only change is with respect to the epsilon closure that we will find in start state, and if it contains a final state then we make the start state also final state. But this rule is applicable only if the final state appears in start state. Okay, so do not get confused that if we find the final state as the part of epsilon closure in any state, we will not make that particular state as final state. It is applicable only and only if the final state appears in the start state's epsilon closure. Okay, so let us see one example and we will understand how we are going to convert our NFA with epsilon to NFA without epsilon. Now as we can clearly see that there are two states in our question, that is Q0 state and Q1 state. So we are going to have only two values in our X. We will not take any distinct values that are going to appear in our epsilon closures or in the transitions, that is P and Q. Okay, so let us start. We will start with Q0 state. The epsilon closure for Q0 is Q0 and Q1. Then the question is incomplete, my bad. Here there is a self loop over 0 and there is a self loop over 1. Right? So here for transitions from transitions from Y over 0 is going to be Q0. And epsilon closure for Q0 will again be Q0 and Q1. Q is equal to transition from Y. Y is the epsilon closure of X. So from Y over 1 is Q1. The epsilon closure for Q1 is Q1 only. Now we will check the epsilon closure for Q1. The epsilon closure for Q1 is Q1 itself. There is no transition from Q1 over 0, so it will be an empty set. So epsilon closure of that will also be empty. Now let us see that we have the transition from Q1 over 1, that is Q1, and the epsilon closure of Q, that is transition over 1, is Q1 itself. Now when we have to convert our NFA with epsilon to NFA without epsilon, we will take the values of epsilon closures of P and Q respectively. We will not consider that transitions P and Q, that is transitions over 0 and 1. Okay, so our NFA with epsilon to without epsilon's transition table will be as follows, that is Q0 Q1, the epsilon closure of P from Q0, and epsilon closure of Q1, that is epsilon closure of Q was Q1. Then for Q1 it will be empty set and Q1, right? So here as we had seen that the epsilon closure has Q1, which is our final state, is appearing in our start state. So we will make our start state also final state, and we have Q1. Here instead of epsilon there is going to be 0, 1. Okay. Now let us take one more example so that we get more clear idea about what exactly is taking place when we are converting our NFA with epsilon to without epsilon. So here we have a self loop over A in Q0, self loop over, this is A, self loop over B and self loop over C. Now since there are 3 input alphabets, there are going to be 3 transitions and 3 epsilon closures that we are going to calculate for finding or converting our NFA with epsilon to without epsilon. So Q0 is our start state. So the epsilon closure of Q0 has a final state. So this will be becoming our final state. The transition is Q0. Again, the epsilon closure of Q0 is Q0, 1, 2. Then transition over B is Q1. So epsilon closure is Q1, Q2. And finally, the epsilon closure for R is Q2. Similarly for Q1 and Q2. Now here you can observe that Q1 is having Q2 as appearing as the epsilon closure, which is our final state, but Q1 will not become our final state, because in the guideline it was mentioned that if and only if the start state has Q2 or the final state appearing in the epsilon closure, we will mark Q, that is Q0 or the start state in our case, as the final state. So let us take the epsilon closures of P, Q and R to mark our NFA with epsilon to NFA without epsilon. So here is our transition table. So we have Q0, which is our start state. Then we have the epsilon closures of P, Q, R respectively appearing in A, B and C, which are our input alphabets. So we will have empty sets appearing, and we have the epsilon closures, whatever were observed or marked as the epsilon closures for Q0, Q1 and Q2. So here we can clearly see this is not, Q1 is not supposed to be our final state. This is just a mistyping. So here we will have Q0 and Q2 as our final state, but Q1 will not be our final state. So I'll just simply redraw this, and we will have much more better and clear idea. So this is our start state, right, which will become final state having a self loop over A. It will go to Q1 over A and B, which is not our final state, and it will go to Q2, which is our final state, over B and C. These are going to have their own self loops, and from Q0 it will directly go to Q2 over A, B, C. Okay, so Q1, as you can observe, is not going to be our final state. Let us check one more example so that we have very much clear idea about what exactly is going to happen here. So in this case we have 1, 2 and 3 as our state numbers. So this 2 to 1 is over A, okay, and we have the epsilon closures of 1, 2 and 3 respectively. We will take the epsilon closures of P and Q. So here there are only 2 input alphabets, so there are going to be only 2 epsilon closures, P and Q, over input alphabets A and B respectively. So let us check how this NFA with epsilon to without epsilon is going to look like in the final answer. So here, as we had seen in the previous slide, I'll take it back again. In the start state has epsilon closure, the start state's epsilon closure is having a final state, so we will mark 1 as our final state. 2 is already our final state, so we will mark 2 also as our final state. My mistake, here 3 is not our final state. So we will have only 1 and 2 as our final states when we will have the final NFA with epsilon to without epsilon. So this is going to be our transition diagram, where 1 will be marked as our final state, 2 is already a final state, but 3 is not our final state, right? So I hope when we are converting NFA to DFA, the method will remain the same irrespective whether the NFA is with epsilon or without epsilon. So that's all for our today's session. In case you have any doubts or any queries, you can leave it in the comment section and we can get it resolved in our next session. So see you then.